Welcome to episode 24 of Ask the Grounding Experts, where our experts from E&S Grounding Solutions answer your engineering questions about the world of grounding and earthing. Today, our founder and CEO, David Stockin, answers the question, what are ground loops? So David will jump through some hoops to explain these loops. It's all yours, David.
Well, that's a good question. What are ground loops? And to be clear, we're not talking about the electrode system called a ground ring or counterpoise. What we're talking about is the old-timer electrician who says, be careful, you're going to cause a ground loop if you're not, careful there. So I hear this all the time. Well, I'm concerned I might cause a ground loop. I didn't want to put that connection because it caused a ground loop. We hear this a lot, and I'm not sure I understand what that means, to be perfectly honest with you. The general thing, what I think it started out as, was an accidental connection from the source transformer between the main panel and the source transformer when they did not bring over a ground wire. They only bring over a neutral and hot wires. You can imagine, for example, a continuous concrete pad with a pad-mounted transformer and then a building on it, and they're sharing a common piece of steel rebar between them. And they only bring over the hot and the neutral, and they're placing a neutral to ground bond inside the main panel. And then they install the ground rod, and it touches the steel rebar. And then the ground rod in the transformer goes through and touches the steel rebar. Now what's happened is there's an opportunity, because we have a neutral ground bond in our panel and an accidental connection, an unintentional connection between the ground rods at both sides. Normal operating neutral currents, this means the neutral currents that are going, we send 10 amps down our branch circuit. We have 10 amps coming back. As it hits that neutral ground bond in the panel, instead of all 10 amps going back through the neutral wire to the transformer, part of it now can go down the ground rod, hit the steel rebar, go across the steel rebar, up the other ground rod at the transformer and back, and it will, right? Electricity does not take the path of least resistance. Sorry to break it to you. It takes every conceivable path it possibly can, just in equal proportion to the resistance it's saying, right? So if you provide that extra path, another metallic path back, it will take it. And now you have neutral currents traveling back on your normally non-current carrying grounded system that people can touch, and that's dangerous. If we recall, and I believe it's in 250.28, there's a discussion in the NEC about how to handle multiple structures being fed from a common feeder source, right, from a common circuit breaker box. And in certain cases, if you have to prove that there's no metallic connection between the two structures. And in other cases, there is a connection between the metallic structures. And this is exactly what we're talking about. If you went up to that transformer, that source transformer, you took your ohm meter and you put an ohm meter on it, you took it over to your panel and it's high, well, that means there's probably no, nearly an open, there's probably no metallic connection between the two. But if it's low, it might be because, the ground rods touch the steel rebar or there's some other connection happening. Maybe there's a below grade ground system. Someone put a loop around the transformer and a loop around your building and tied them together. In that case, the neutral ground bond in your panel must be removed, right? We see this in 250.6 and in at least 12 other places within the code. Do we see the requirement to remove those to prevent what's called objectionable currents? Objectionable currents, again, are neutral currents returning back to the transformer on the grounding system, and that's a big no-no. It's very hazardous. It's very dangerous. We want to prevent that. So this is what my understanding of a ground loop is. It's an unintentional connection allowing neutral currents to travel back. It is not because you added an extra connection or added another ground rod. These don't cause loops at all. In fact, when it comes to a ground loop and the idea of a ring around a building, we actually like those. They're one of the most effective electrode system we know of is a ground ring, right? Circumnavigating your building and bonding it up to the building steel and up into your system. These are the single best methods that you can, electrode system you can have for safety and for effective grounding, reduction of electromagnetic interference, lower resistance ground. Every factor, a ground ring is ideal. But that's not what most times when you hear the old timer talk about a ground loop is talking about. They're talking about causing a normal operating neutral currents travel back on the ground system in violation of NEC 250.6. The other place this happens oftentimes is when you put in an automatic transfer switch. You have 3-pole, 4-pole transfer switches. In one case, the 4-pole, right, you need a neutral ground bond in the generator, but in a 3-pole, you do not. They get that mixed up, and now all of a sudden you have, again, you're allowing neutral currents to travel back on the ground system. When you're designing your circuits, always remember you have to check the normal operating condition to make sure that 100% of the neutral currents stay on the neutral wire, and then put a fault in the system and see what happens when a fault occurs and trace it out. And in a fault condition should go onto the grounding system to get back to the transformer. But in all cases, the fault current has to get back to the transformer. Remember, all faults clear through the source transformer, no matter where that transformer is located. If you have a metallic path back to it, it'll stay on the ground system. If you don't, it'll travel through the earth to get back there. At the level of the NEC, you're not allowed to use the earth as a conductor. Only at the level of utility companies are they allowed to use that. So, what are ground loops? Ground loops in the old-timer sense are accidental connections that allow neutral currents to travel back, normal operating neutral currents to travel back on the ground system. That's a violation of NEC 250.6. It's very dangerous. You don't want it. And you can check it real quickly. Grab your amp meter and check your ground wires. Get an IR camera, put them on your ground wires, see if you have any current flowing on them. You should have very, very low current, well less than half an amp. Most cases well below 100 milliamps easily. And you can tell if you have that. If you do, if you have greater than that, you should do a check and quickly find out why you have currents coming back on your ground system, because they should not be coming back on your ground system during normal operating conditions. Only during fault conditions should your ground system be utilized as a fault current path. Okay, I think that'll wrap us up for today. A nice short one. If you're listening on our podcast, please hit subscribe and leave us a review. If you're watching us on YouTube, hit that like button, leave us a comment. Lots of information down below, links of stuff to good information. Please check out our website. Tons of good material in there. Leave us a comment, give us a call, send us an email. We'd love to hear from you. Thanks a lot.
Thanks so much for watching. If you found this episode helpful, please give us a quick like down below and subscribe to stay up to date on future educational videos we will be publishing. And feel free to post questions or comments below as well. We might even feature your questions in future videos. If you'd like to learn more about the amazing world of electrical engineering and grounding, be sure to check out our certified online courses at the links in the description below to kickstart your career. See you next time.